Hey folks, tools like Claude Code or Codex or Cursor, they feel a bit like black magic, right? Well, today I'm going to show you that there is zero black magic involved because we will be building our own Claude Code killer. Nah, I'm kidding. But we will be building our own AI coding agent so you can see what the fundamentals are and what's involved. And spoiler alert, it's only 200 lines of code. So let's dig in. And there we go. And as you can see, there is actual JavaScript code in here that gets called and evaluated. So that is pretty cool, right? We just built our coding agent in 200 lines of code and it can do anything Claude Code can. Kinda. Now, the inspiration for this video came from a blog post and a talk by the AMP Code crew, Thorsten Ball and Jeffrey Huntley. So if you want to dive into the original blogs, they're in the description below. All right, now what do we need to get started? Turns out you don't need much. You need some programming skills. You need to be able to write CLI programs and talk to an HTTP web server. And secondly, you need access to a large language model. Now you can use the frontier models like Claude Sonnet or GPT-5, whatever, or you can go for a cheaper route, especially for this exercise, which is using cheaper models or even running your own model. And that is what I will be doing today. I am running like a very old, very small Quen Coder model on this laptop here. So it's all local, or at least it's on my local network. And that's actually all you need. So basic programming skills and access to a model. All right, first we need to get some fundamentals down. And the first one is a 30-second recap of what a large language model is and how it works somewhat. So you can treat a large language model as a black box, and it's a stateless thing that takes input, which is like messages or commonly called prompts, and then one token at a time, it generates a response. And for each subsequent token, it needs like all the previous things, so your prompt and things, but that's already going into too much detail. All you need to know is that it's text in, text out, and it's a very low level technology. Now, that will not be fun to program with, but there are some SDKs. The most commonly used ones are the OpenAI ones that provide a thin layer above this. And what these SDKs give you is a way to send messages to a model and receive like the entire completion, so the entire responses. And you can stream them, and you can do all kinds of crazy stuff. So you can think of these OpenAI SDKs as like a thin abstraction layer above LLMs that allow you to do text in, text out kind of protocols. And that's what we will be using to build our first AI coding agent. So what exactly is an agent? Well, if you have these basic building blocks, like a stateless thing, message in, message out, that's like programming in Haskell, right? No side effects means no interesting software. But when we talk about agentic AI, we enrich this thing so that it can sense and impact its environment. So it can see things that are happening that are not like directly in its prompt, and it can do things that are like not in its immediate control. And for coding agents, what we will be building today, seeing the environment is like having the ability to read files, to open files, to list directories, stuff like that. And impacting the environment, typical coding agents, they can write text or code to files, and they can run shell scripts to compile code, run unit tests, stuff like that. So that's what we mean when we say agentic. All right, so we will be building this coding agent like step by step incrementally. And let's take a look at the first step, the first iteration, which will be very bare bones, but bear with me. We are just gonna write an AI coding agent that you can talk to, you can send a message, and that'll go and talk to a large language model, and it'll just print out a response. So it's a very basic walking skeleton. And let's grab the code for that. So it is 50-ish, 70-ish lines of code, but it's a lot of boilerplate in .NET. So it's 50 lines of code. What actually are we doing? We are using the OpenAI client to talk to models. And as you can see, I'm running a model somewhere in my network using Ollama. And it is Quen 2.5 coder 7b instruct. Doesn't really matter, but it's very small model I can run on my consumer hardware. And then we just connect to that LLM provider, that model provider. And then what happens when we run our command or our application? We just ask for input, like Claude Code would do. We ask for a prompt, and then we process it. And as you can see, it's like a game loop, a main loop that keeps doing this until you want to stop. And let's take a look at what happens if you ask a question or like submit a prompt. We just wrap it into some types and then say run inference. That's the technical term for like generate some tokens for me, please. And we print that out to console. Now, what does running inference look like in this Hello World example? Super simple. We just use that client and we say, okay, just complete this message, just provide a response. And then we just return the string result. And that's it. So now let's see that in action. So yeah, it's booted up, and let's say, hello there. And there we go. We have a REPL, and we can talk to a model from our command line. Now, this isn't doing much, right? But let's build some extra sauce. Let's put something on top. So the first thing you will notice when you have this Hello World up and running is that it's really dumb. And when I say really dumb, I mean really dumb. So let me illustrate this. Let me tell it a secret. So now I just told my LLM the secret, and now I'm going to ask it about the secret. So I'm asking, what was the secret again? And it has no clue what we're talking about. What's happening? Well, one thing we glossed over in the introduction is that LLMs are stateless, so they do not keep any track of any state, and even that SDK, that wrapper around it, does not keep track of any state. That's just there to allow you to send messages to an LLM and to like get responses back. So how do we get how does Claude Code get its memory, like a conversational memory? Well, the trick is it's actually all kept in the agent code, so in the thing we are building. So what we are going to do is we're going to store a conversation, which is nothing more than a list of messages. And we're going to store both the things we are saying and the responses that we got from the LLM. And then as a next step, every time we ask a new question or send a new message, we are going to upload or send along the entire conversation history to the model. So it has like track of everything that has been said before. And that's actually how these models have conversations. So let's now go to the code and take a look at what this looks like in practice. So as we just discussed, you just need to keep track of a conversation. And in my hacky implementation, that's just a list of all the chat messages that get sent and that we received. So that's what you see here, this conversation list. And then not a lot changes actually, except where we are running inference, we're just adding every message we send to this list and adding every response we get to this list. And that is the only difference, except that when we run inference, instead of like sending just the last message, we send the entire conversation. Now, one other thing to note is what you can see here. There are different kinds of messages, and those are just tags that like say, okay, this was originally a message from the user, or this was originally a message from the model itself. So there's like a real script, like a play or a movie script that has like all the actors in it. And that is actually all you need to keep session state or conversation state. So let's see what it looks like. All right, so let's try the secret again. And now let's see if it remembers. There you go. It knows about secrets. It keeps track of the conversation history. So that's how you keep track of conversation. All right, now we're getting to the good stuff, tool calling. So let's make our agent actual agents that can sense their environment and can like write to their environment. So first, we're gonna do this with ChatGPT in the browser, just to have like an idea of what we're going to do, and then we'll write some code to do the actual tool integration. But first things first, how does this work? Because large language models, as you know, it's text in, text out. They cannot execute code. They cannot run commands. So how do tools actually get integrated? Actually, with a clever hack by reprogramming these models. Because what happens is next to your conversation and the prompts you're submitting, there's a sneaky secret message that gets sent, and we'll take a look at it in a second. But that basically tells the agent, these are the tools you have access to, and this is how you should signal that you need to call a tool. So that's just another message, just another prompt that gets sent over the wire to the model, and then the model knows about tools and can execute them. But what does that actually look like, executing a tool for a large language model? For that, we can go to ChatGPT and take a look at an actual tool description list. So let's take a look at this prompt before I fire it off. We're telling the model that it has a list of tools. And if they feel like they should be calling a tool to answer your questions or obey your commands, they have to respond with some JSON, some JSON. And that's not valid JSON, but okay. So they have to respond with some JSON, basically requesting a tool call to happen. And then we will do the actual tool call, like me in the browser typing the answer, or when we build our coding agent, we will write some code that does that for us. So no mechanical Turk there, but that's the idea. And then as an example, let's give it ChatGPT a tool list here that is like, okay, we have one tool, it's called get secret. This is what you can do with it. It takes no arguments, and this is what you get back. So we're just telling it that we have a get secret tool that ChatGPT can use to find out about the secret, and takes no arguments, and it'll return the secret. So let's reprogram ChatGPT with this tool list. So it got the message, we're good to go. And now let's send a prompt asking about the secret. And as you can see, it answers, but it answers with a request for a tool call. It's saying, hey, I need a tool call for this to work. And the tool we're calling is get secrets. So now pretend we are the coding agent and we see this response. Okay, we need to do a tool call. So let's pretend we do that and we found the secret. So now let's return the secret. I don't know why I'm picking fruit, but now we responded with a tool response. And ChatGPT just sees it and can continue its work. So this is in a nutshell what tool calls look like. Now let's implement that. All right, so now let's implement tool calling in our coding agent. The only thing that changes is that when we get a response, an assistant message is what it's called in the OpenAI SDK, we investigate that response, and if it's a tool call, we do some tool calling, and that's actually the only difference. So let's take a look at what I'm doing here. I'm just taking a look at is the response JSON or not. If it's JSON, it's a tool call, and we take a look at the request to perform the tool, otherwise not. That's not actually how tool calling works in most models and most clients, but it is with the model I'm using and Olama, the model provider I'm using. So there are better ways if you're building your own coding agent than trying to parse JSON, basically. But it works for this demo, so that's why I'm going with it. So yeah, this is where we're parsing JSON to see whether or not it's a tool call. And just as we did in our ChatGPT demo, it's just the name of the tool and some arguments if that's relevant. And then when we have our tool call parsed, if I can navigate back at least, yeah. So if it is a tool call, we do a tool call, which is what you can see here, and then save that tool call as another message in the conversation history as we do for user messages and assistant messages. Now we also have tool messages, and that gets sent to the LLM with every prompt we do. So that's how the LLM receives tool responses. So let's take a quick look at running a tool. The secret tool that we just demoed is a hard-coded thing, but this is where the magic will happen. This is where you can look up files, read files, edit files. So this is how tool calling works in practice. And as you can see here, our secret of the day in our actual tool is key lime pie. So we're still somewhere in the fruit area. And now let's demo this. So I'm going to ask it, what is the secret? And as you can see, it did the tool call response. And then our agent picked up that response, parsed it, and executed this line of code. And that is exactly what the model got and what the model returned. So that's basically how tool calling works. Now let's make it a powerful coding agent so it can write files and read files and execute code. So let's now make it a quick real coding agent so it can read files, write files, and execute code. And typically you give these agents different tools for the job, but I was spending way too much time on this. It was fun though, but I was spending way too much time on this, so I gave it God mode and I gave it access to PowerShell. And it's a scripting language for Windows, and with that you can do anything. So you can read files, create files, run code. It's a shell basically. So I gave it access to PowerShell, as you can see. It's just the same approach as the secret thing we just saw. And the input arguments are actually a bit more involved because we need input, like what file are we trying to write, what are the contents of the file, what command are we trying to run. So that's what you see here. Now it's basically just like explaining the method signature or the tool signature. It's saying like, okay, this tool takes a script argument and it's a string type, and this is what you should put in it, and it's required, stuff like that. One final thing to note, this is like very proprietary. It's the OpenAI specification. The Qwen models have their own specification, but there's a bit of standardization around this. Whenever you hear the term like MCP server, they solve a large part of this, like being a standard interface for like tools and for protocols, but that's something else. So yeah, this is where MCP fits into the picture. So with this, we gave our LLM like knowledge about the tool, but what was the actual tool calling? What does it look like? There we go. So if we receive a tool request for PowerShell, we just run it, and it's 2 lines of code again, or sorry, 1, 2, 3, 4, 5 lines of code, which literally creates a new PowerShell script or a shell and executes that script and just echoes back whatever this script returns. So that is it. Now, let's see it in action. All right, so our coding agent is done. It has PowerShell superpowers. So now let's see it in action. I prepared a short demo because the model I'm using, Qwen 2.5, it's a big difference in quality to what you're used to if you're working with frontier models like Claude Sonnet or GPT-5. So this is somewhat carefully crafted. But it's just to get the idea across, right? So we will ask our coding agent to program something in JavaScript to create a 1-line script because I was messing too much with new lines. And it should be able to write a script that calculates factorial of 10 and then save that JavaScript code to a file called fact.js. So let's fire that up. As you can see, it's doing tool calls here. All right, so it did something. Now let's ask it to run that code using Node, which is like how you execute JavaScript on your machine. As you can see, it's doing another tool call, and there you go. It returns the result. And now to make sure we're not cheating, let's take a look at our file system. So yeah, there is a FAQ file in there, and let's open it up. And there we go. And as you can see, there is actual JavaScript code in here that gets called and evaluated. So that is pretty cool, right? We just built our coding agent in 200 lines of code, and it can do anything Claude Code can. Kinda. And that's it, folks. With just 200 lines of code, we just created our own coding agent. Now, I think I'll stick with my day job and I will not be building the next Claude Code killer, but I hope this demystified coding agents for you. It's just an HTTP client, a game loop, and some tool calling support, basically, and all the rest are bells and whistles. So yeah, if this breakdown helped you demystify the black magic that is coding agents, please hit the like button and share this video with someone that would be interested. And if you have some hours to spare, I highly encourage you to build one yourself. My code is available on GitHub if you want to take a look at it, and I hope to see you again next time. Thanks for watching. Bye bye.